Our next one, let's take a look here. Now we're going to take a look at this equation. We're going to take a look at two ways to take the derivative here. We should recognize this shape as a circle. So the first way I'm going to solve it is using my implicits, my new rule, implicits, implicit differentiation. So if I were to take the derivative, this is super easy to do. You'll probably go faster than me. We get 2x plus, when we take care of the y, this is our new rule, we get 2y dy dx. My power rule, 2 times y times my inside, the y, which is dy dx. And that's going to equal 0. So therefore, dy dx, and if you solve it, you get negative x over y. This will find the slope of a circle at any given point on that circle. The next way I want to solve it is using explicitly. To do this explicitly, we have to solve for one of our variables. I can easily solve for y. We get plus or minus the square root of 4 minus x squared. Plus or minus because we're taking the square root. But now when I take the derivative, and right away you're going to notice a big difference, we have to use chain rule, and this isn't even a nice one. Dy dx equals plus or minus, bring down your power to the derivative of the outside, 1/2 4 minus x squared, right? Then take the derivative of the inside, time, oops, that should be negative 1/2. Because you have to subtract 1, times the derivative of the inside, negative 2x. Now the 2's cancel, makes it a little bit nicer, but here's my derivative. Dy dx becomes plus or minus, on top, negative x over the square root of 4 minus x squared. Now the question is, here's my derivative explicitly, here's my derivative implicitly. Are they the same? The plus or minus really doesn't really matter much because it gets absorbed, this minus gets absorbed in there. But if you look at, remember when we first solved for it explicitly, what did we get for y? Plus or minus the square root of 4 minus x squared. I can replace that with y, and they become the same exact equation. The question is, which is easier for you? Of course, this one. So kind of our lesson is, if you have a function that's not solved for y, just take the derivative. If you're solved for y, well, it's a little bit harder. Right. Our last example we're going to take a look at is what's called the second derivative. Now, the first derivative is going to be super easy on these. The second derivative, not so much. And you will see a question like this on your test and your quiz, in your dreams. Okay? This will haunt you. This is the hardest derivative you will ever take. And it looks so friendly. Look at it. It's like nice. It's like, hey, you want to come home, meet my parents? I don't know. But when we take the derivative here, be very careful again. We got this xy rule, which is our product rule. So I'm going to go start by taking the first derivative. Be careful the y squared. That becomes 2y dy dx. Plus, here's my product rule. I always put this in parentheses. The first times the derivative of y, which is our dy dx, plus the second, which is y, times the derivative of x, which is 1. And again, that's just going to equal 0. Anything that has a dy dx will stay. So plus x dy dx. The y goes to the other side. And again, most of you guys will be able to go from here straight to your answer. I just show that step just for the algebra. I know I'm going to divide everything by dy dx, factor it out, and I'm going to divide by what's left. So that's going to give me negative y over 2y plus x. And there is our first derivative. Piece of cake, right? Yeah, Mr. Werner, this stuff is cool and cool. Alright, so now we're going to look at our second derivative. Same as the first, but a whole lot worse. Alright, let's take a look at our second derivative. Now to do this, we're going to take the derivative of both sides. Now the derivative of dy dx, This is my first derivative, so its derivative will just be the second derivative, d2y dx2. The location of the 2's is important. Equals long fraction bar. Okay, here we go. Quotient rule. We're going to use our quotient rule here. Low, 2y plus x, d high. Well, what's the derivative of y? Negative dy dx. That's my implicit. Minus high, which is negative y, so I'll make that a plus y. D low, which is 2 times the derivative of y, dy dx plus 1. Barely had enough room on my fraction bar, divided by the bottom squared. There's our derivative. But the problem, as you notice, is we have a complex fraction here. We don't like complex fractions. So what can we do? That's right. We can replace dy dx. I can replace that with my derivative that we found earlier. So now I'm going to rewrite this whole thing. Need a little more space. Big fraction bar. 2y plus x times negative of my derivative, so that becomes positive y over 2y plus x, plus y times 2 times negative y over 2y plus x, plus 1, over 2y plus x squared. Not done anything really complicated yet. Now I don't like the fractions here in the bottom, so I'm going to multiply by that LCD. We've been practicing this for a few days, right? We've been practicing this. 2y plus x. 2y plus x. And I'm going to distribute. If I distribute to the first group, those cancel out. And what I'm left with is 2y plus x times y plus, now over here I'm going to do two things. I'm going to distribute and distribute at the same time. This becomes 2. If I distribute here, that cancels. This becomes, sorry, not positive 2, becomes a minus 2y squared here. And then plus this y gets distributed, and also this 2y plus x gets distributed. I distribute here just because there could be an error with the algebra on this one. And I divide that by 2y plus x cubed. There's my answer. There's my second derivative. Now, what gets people lost on this one is the algebra. But that's why we practice that LCD method right here, to get us better at it for this. Okay, so now, that's my answer. Totally acceptable. But we can go further. I can simplify this. If I distribute the y here, I get 2y squared minus 2y squared plus 2y squared. So that just becomes 2y squared. I get xy plus xy, so plus 2xy. I mean, this cleans up really nicely, and I would accept that. But then there's always somebody who says, yo, Mr. Wernow, what if I factored out the 2 on top? Over 2a plus x cubed. I would accept this. But why would you want to factor out the 2? Why would you want to have y squared plus x squared? What is y squared plus xy equal to? Up here, y squared plus x squared is 25. So this right here is just 25. So my final answer, if you simplify it all the way, is 2y plus 50 over 2y plus x cubed. And that's as simple as you can make it. Now, you don't have to go this far typically. Remember, we just want the derivative. But on your homework on tomorrow, you're going to have a question where you're going to have to simplify it some more. Okay? All right.